Let's look at adding or subtracting now. Suppose we have two masses, 2.5 kilograms and 174.38 kilograms, and we need to add these up. Well, note that the mass M1 can be anywhere between, let's say, 2.4 and 2.6, and this mass can be anywhere between 174.37 and 174.39. That is, as usual, the last digit to the right is unreliable, right? This 5 is uncertain, this 8 is uncertain. So let's see what the consequence of all this would be. When we add these two numbers, we get 176.88. The question is, can we report this number as it is here? Now let's look at M1 again. M1 is actually between 2.4 kilograms and 2.6 kilograms. And M2, we're going to say it ranges from, let's say, 174.37 to 174.39 kilograms. If we add these up, we get 176.77 kilograms, and if we add these over here, we get 176.99. So notice that in this range, these three numbers here, 176, we don't have any problem with these. So this is where the variation begins. So that means then we should round this off to 176.9. So whoever reads this will understand that these digits are being stated with certainty and that this digit is the uncertain one. So that's what we have here. So the rule of thumb is simple. Whenever you're adding or subtracting, you just look at the two numbers and note the number of digits after the decimal place. So in this case we have one digit after the decimal place, and here we have two digits after the decimal place. So the answer has to be rounded off to one decimal place. Notice in this case we're not looking at the number of significant figures. Obviously this has two significant figures, but the answer here has four significant figures. It would be wrong to round this off to two significant figures. So in addition and subtraction, it's the number of decimal places that we look at. So let's do some examples. So here we're given the task of finding the area of a rectangular strip of land, and these are the dimensions. So as is usual, we calculate the area by saying 0.415 kilometers times 26819 kilometers. This gives us 11,129.85 kilometers squared. Of course, we can't report this like this. So if you're going to report the area, we have to say, well, how many significant figures do we have here? We have 5 significant figures. Here we have 3 significant figures. So this answer needs to be rounded off to 3 significant figures. And so we get 1.11 times 10 to the 4th kilometers squared. So notice it's the number of significant figures that we look at. Of all these numbers that we multiply, the one that has the least number of significant figures, well, our answer has to have that number of significant figures. So here, this has 3 significant figures, this has 5 significant figures, the answer has to have 3. Notice the importance of scientific notation. To communicate that we only have 3 significant figures in our answer would be impossible without scientific notation. If we went to record this as 11,100 kilometers, written this way, these zeros would be ambiguous. There would be no way of knowing whether or not these zeros were significant. In this case, we're given the task of calculating a density. So we know the mass of an object and we know its volume. And in order to find the density, we need to divide the mass by the volume. And so this is the symbol. It's the Greek letter rho. And very often we use this symbol to represent density. So when we divide 0.0372 by 0.000040 meters cubed, we get 930 kilograms per meter cube. So how do we report our result? Well, if you look at the numbers we used, this number has how many significant figures? It has 3 significant figures. Whenever in doubt, express the number in scientific notation. So this could be written as 3.72 times 10 to the minus 2. So this is 3 significant figures, and this is 2 significant figures. So the answer should be expressed with 2 significant figures. Here, as we have this number, we are not able to communicate the number of significant figures. somebody looking at this could not tell if it's 3 significant figures or 2 significant figures. So we report the density as 9.3 times 10 to the second power kilograms per meter cube. If for some reason we needed for this number to have 3 significant figures, then we would simply say 9.30 times 10 to the second power. Okay, so we're supposed to add these two numbers here, and when we do, we get 87.33. And we look at these numbers we used. This one has 2 digits after the decimal place. This one only has 1 digit after the decimal place. So that means our answer must have only 1 digit after the decimal place. So we report this as 87.3 meters. So notice what we consider here are the number of digits after the decimal place. We don't concern ourselves with the number of significant figures. The focus is different. Turning to subtraction, if we subtract these two numbers, and let's assume it's the larger minus the smaller, when we subtract these two numbers we get 10.94 meters. But if we look here, this has 2 digits after the decimal place, and here we only have 1. So our answer must have only 1. So the answer should be reported as 10.9. Right? So we round this off to 1 decimal place. So again, notice we're not concerned with the number of significant figures. Here this number has 2 significant figures, but our answer that we're going to report has 3, because we're not focusing on the number of significant figures, we're focusing on the number of digits after the decimal place. And so this has 1, so the answer must have 1 digit after the decimal place. So that brings us to the end of this section then.